This is Saxon's Trig, Lesson 11, beginning on page 83. It is about circles, properties of circles, and the quadratic formula. So in part A, we begin with lots of terminology and what should be review of this terminology for circles. So a circle has a center point, and all of the distance from the center around must be the same. That's what makes it a circle. From the center to any point out is the radius of the circle. We also have a chord, which goes from side to side, and a specialty chord goes through the center from side to side, and this one is the diameter. We also have, if a line cuts through, then this is a secant because it's a line going all the way through. And the final one is a line that doesn't go through but touches at one point on the outside of the circle, and that is a tangent. So again, to review, radius is from the center out. Chord goes from side to side. A chord is a piece of a secant, where the secant is a line going all the way through. A special chord going through the center for all the way from side to side is the diameter, and a line touching the outside of the circle in only one spot is a tangent. Now, there is a special rule about every radius and a tangent, and you'll see in the book they drew a 90-degree box here in that corner, which means the other side is also 90. That rule basically says every radius and tangent must form 90 degrees or they will be perpendicular, meaning the same thing. So that is the start of the terminology. Now, I think we talked before, but they review again that when we want the perimeter of a circle, we are looking for its circumference. So circumference equals perimeter. And they did not review the formula there, but in case you want it again, it's pi times diameter. Then they move to arc. So on a circle, if you talk about a section of the curve, that's an arc. If this in degrees is less than 180, it's going to be a minor arc. This one going the other direction is more than 180, so it is a major arc because it's more than the 180. If the arc is halfway only, then it is a semicircle. Because it's half of the circle. What else? Arc, semicircle, central angle. When you start at the center and you cut an angle inside of the circle, this is a central angle because it is an angle at the center of the circle. We define an angular measure of an arc to be the same. It's saying if this is 10 degrees inside here, the matching arc will have to be 10 degrees. And I believe we covered that in an earlier lesson, but it is worth reviewing for sure. All right, we've done major and minor arc. We've shown semicircle. And the naming of an arc. So if I labeled some things here, A and B, then if I'm talking about just this outside piece, I'm going to use the two letters A, B, and we're going to put an arc symbol above it for naming it. Now, if there were another letter here, such as C, you could name it A, C, B with an arc, but you only need two letters. I would use three only when I am trying to clarify between A, B could imply this direction as well. So if I want to talk about the minor one, I'm going to use AB, and then let's say there's a D here. If I want to clarify, I want the major arc, we are definitely going to do A, D, B, because now I know that I'm going through D before getting to B, and I'm clarifying that it is the major arc that I want. And those are read as arc, BAC, arc, AB, whatever it's going to be. And semicircles can either use the 2 or the 3 letters. It's fine. On page 84, they talk about the measure of an arc being the same term as angular measure of the arc. So you can see why we would use the shorter measure of an arc. And that mathematical abbreviation is measure of arc AB. And it could be equal or congruent to another measure of another arc. Then in part B, they move on to properties of circles. Okay, so we've talked here about the fact that if it is a central angle, it is the same measurement as its arc. When I have an inscribed angle, so not coming from the center, but it's inside of the circle, if this is 44 degrees, its arc that it cuts will be double at 88 degrees. So the central ones are the same. The angle is half of the arc that's cut, or the arc is double the angle. Both ways work. If my inscribed angle has the diameter as one of its sides, then it is cutting a semicircle for sure. And they're talking about this. If you form a triangle here, it has to be a right triangle. If you think about that, that's true, because I just said an inscribed angle is half of the arc that it cuts. Let's look at this one. So a circle is worth 360. Half of that is 180. And this angle is cutting an arc of 180. Therefore, it's half, and half of 80 is the 90, and 90 means it's right. That's their explanation there. Okay, I'm going to ignore their other dark words here about constructing the right angle. We've covered what you need here. Now, if you have this circle and you have any kind of a polygon shape inside of it, we know that the full measurement around is 360 degrees. So if I am finding all of the addition of these, and these angles have to total up to be 360, that is what you're getting here inside the polygon. These same 4 must total to be 360. Because of that, if you put this angle with this angle, it must always equal 180 degrees. So any 2 opposite angles in a polygon inscribed in a circle will total to be 180 degrees. So these 2 would also be totaling to 180. Top of page 85, what happens when we have chords that are crossing inside the circle? And they label these pieces X, Q, P, and Y. They form a I'm saying this badly. When you multiply the 2 parts of these chords, they will equal the other side, because the chords, if they're going the full direction and touching side to side, they have to be the same in length. So X, Y has to equal P, Q multiplying together, because the chords have to be the same length inside that circle. New thing, did they use the same? They did. Okay, so I'm going to go ahead and use this shape and do what they did in the next one, which is basically connect those and make triangles here. And then this was labeled B, and they labeled this one A, and they've marked that this angle has a single tick mark and this angle has a single tick mark. So I know that those 2 angles are the same. All right, so this angle is cutting that arc. This angle is cutting that same arc from here to here. And because they're the same and they're cutting the same arc, I know that this is double what those are. And if I need to solve, I am the other piece. Okay, so does that make them have similar triangles? This angle and this angle are the same. These two are the same because they're vertical. Yes, the third ones would be implied to be the same. That being the case, then I know I can set up proportions. So X from this triangle is going to match with Q from this triangle, and P from this one matches with Y from this one. And because they were similar triangles, I set up that proportion and I can cross multiply to solve. That would also give me that same XY equals PQ. It's just a way of proving that mathematical formula actually works in multiple ways. Next one you need on middle of page 85 is about tangents. If I have two tangents touching circle two different places, this one is labeled M, they labeled this one N, and this shared point was P. And we know that there's a rule that says that the radiuses, if I draw them in, they have to form 90 degrees where those cross. That was that rule we did up here. And they're wanting you to kind of do, sort of give you a proof, a rough outline proof of why you know that M and N have to be the same in measurement. That's the rule. If they're both tangents, then this length and this length must be the same. So let me go ahead and finish the thought process of that rough proof. They'll do it formally in another lesson. But if I take this radius and I connect it here so that I have two triangles, I know they're both right triangles because of the 90 degrees inside. This side is a shared side, same in both. So if I were doing a formal proof, again, we'd have our 1 and our givens, and then our 2 would be that, let's call this O. OP is congruent to OP because that's the identity line, that's its reason. And then would this side match this side? Yes. So again, if we labeled this A and this B, my third step would probably say something like AO is congruent to BOY because they're both radii. That would be the reason. And that gives me angle side side or side side angle in my step 4. And then step 5 would be this side matches this side because of that lovely CPCTC. So we know the rule works based on that proof that two tangent lines must be the same in that environment there with that circle. Let's look at example 1. Find X and Y. Their triangle is connecting here and here, and this was B, A, P, and R. And this is given at 46 degrees. It's tiny enough, I'm gonna have to write it as a dot. This one is 30 degrees. This is Y plus 20 for this angle, and this one is X plus 10. So they want me to solve for the X and the Y. So I'm first going to look for, are any of them central angles that would be the same? No, they're just two chords that are crossing. So I'm going to look for arcs that are cut and shared. This angle, which is labeled with the X plus 10, cuts this arc AB. This angle cuts the same arc AB. So that means 46 degrees is that angle, and it cuts the same arc. So I do not know what the arc measurement is here, but if this is 46, my rule says this arc is doubled. So 46 doubles to 12, so 92. And instead of writing the arc AB, I can fill in the 92. So then X equals minus the 10, 82. Oh, X is not necessarily degrees, it was just an X. And then it wants Y. Oh, I was trying to find that answer. to check it. Oh no, x is 36. Did I mismultiply something? No. Oh dear, I know what I've done. Yes. Okay, yes, this arc is doubled to 92. However, since these are both the same angles that are cutting that arc, they're set equal. So x plus 10 is not equaling the doubled up arc, it needs to equal 46. And then 46 minus 10 is 36. That's matching much better. X is 36. Okay, now let's do the same thing for the y's. This has the y plus 20, and it's cutting arc PR. So I know that they're going to be equal. Is there something else that cuts that same PR? Yes, this 30 degrees. Now let's set it correctly. So we're going to change this to be 30 degrees, and then y equals 20 from 30 is 10. So y equals 10 and x equals 36. There, I fixed that so you can see that a little more clearly.